Hi, my name's Callum. I'm the lead trainer for Training Bite Size, and want to take some time to talk through critical path and how it works. So we're not going through what it is necessarily. We're talking more about the mathematics here. A couple of things you'll need to make sure you are familiar with prior to this, or sort of to make sense of anything we're going to go through, is the work breakdown structure. Very brief summary of the work breakdown structure, though, is there's a hierarchy. Showing a hierarchical diagram showing all the tasks we've identified or think we need to do to deliver our project. What they will not show is the order. The work breakdown structure is a family tree, is how I've always remembered it, but basically a hierarchy with the highest level of detail at the top of the hierarchy, and then the lowest level of detail, the most information, at the lowest level, at the bottom of the hierarchy. As I said, it doesn't show any order, though. So what the critical path is about, or sort of starts off with anyway, is about determining the logic, the sequence between tasks. So I can't install something until I've had it delivered. I can't have it delivered until I've chosen it, and I can't choose it until I've researched which one I want. So there's a logical dependency, and I'm going to use the word dependencies. What I'm not going to go through today is the different types of dependency. There are several, but I'm just going to use the most traditional, which is finish to start, i.e. one task has to finish before the next task starts. So what I've got on screen at the moment is some tasks. So in a real project, these won't be with letters in the middle. They'll have your work task name and ID from your work breakdown structure. So I've just used letters to keep things simple. So instead of the letters in the middle, you'd have task name and ID. These are called nodes, these boxes. At the moment they're jumbled up, they don't mean anything, but what we're going to try and do with our critical path, or before we can do a critical path, is to determine the logic. So what order these go in. So what we'll say is, we'll keep it nice and simple, and we'll say A is the first task. So like if you're familiar with Gantt charts, you work left to right, so you start on the left, you go right. Same with a network diagram, which is what the critical path is done on, or you may have heard it called things like precedence network or precedence diagram or simply network diagram. It doesn't really matter. I've generally called it a precedence network just to cover all bases. But what we're going to do is create this network diagram. So we'll say that task A is the first task in the sequence. And we'll say that task B cannot begin until A is finished. So if we're working left to right, task B would go to the left of A. Now, let me just move D out of the way. To show the network, show the precedence, the dependency, the order, so that A has to finish before A can start. B can start. Sorry. We draw an arrow. So there we go, and that shows that visually that B cannot begin until A is finished. Just make the arrow a bit thicker. Because I know there's other tasks on the way, I'm going to move B up here. Oops. And we'll say that C cannot begin until A is finished as well. And that we'll put C to the right of A, and then we'll draw another arrow. There we go. And that shows that A has to finish before B and C can start, but because B and C are not dependent on each other, I've not said anything about B having to be done before C or vice versa, whatever. A has to finish before B and C, which means if we have enough resource, we could do B and C at the same time. Carrying on that dependency there, again, this is something you'll see when you turn this into a Gantt chart. I mean, when I say you turn it into a Gantt chart, quite frankly, most people don't do this nowadays. It's not surplus, I suppose. Software does this in the background when you create your Gantt charts and stuff, but it's becoming a bit of a lost art, I suppose, in how these work. I like them. I think they're useful for planning, but nowadays I think I'm in a bit of minority on that. I've always liked to do these visually with little cutouts and things to work out the logic and then turn it into a schedule, but hey ho. So we'll say that D cannot begin until both B and C have finished. So if I move D up here, so this task here cannot begin until both B and C have finished. So I draw two separate arrows going to D, and that then shows me, or shows my stakeholders, if they're asking to see what the order is, that D has to wait until B and C have finished before it can start. And that shows that dependency then. That'll be reflected on your Gantt charts as well. If you've seen Gantt charts on Microsoft Project or Primavera 6 or whatever you're using, you might see arrows on them. That's what the arrows mean. Just going to throw a bit of a curveball in here. Task E cannot begin until A has finished. So I'm not going alphabetical. I'm going to, again, I said, throw a bit of a curveball in. We'll say that E cannot begin until A is finished. So that would then show that E could in theory be done at the same time as B, C as well. Because A has to finish before those three can start. So what that means, the reason I've put them in parallel is because it shows clearly to stakeholders who may be looking at this or want to see this, for whatever reason, that those three are not dependent. So B, C, and E are not dependent on each other, which means I could do them in parallel if I have enough resources. Equally, though, it doesn't matter if I put them out of sequence with each other. So I could do B before C or C before B. It doesn't really make any difference as long as A is finished. So we'll say F cannot begin until E is finished. So the reason I like to do this in parallel is because it just shows you where the resources there might be spikes in resources and things like that, you see. I've always liked projects as a picture. That's why I've always liked things like Gantt charts. If you ever come on a course with me, you'll see me doing lots of drawings and doodles and sketches and things. I've always found that quite helpful. And then we'll finish off with G. And that shows the logical sequence. So this is the network diagram, or precedence network, or precedence diagram, whichever your choice of name is, and that now shows the dependencies. So the critical path bit then, there's some information that goes on these boxes in these nodes, these are called, these boxes. So I want to just sidestep before I go through what the critical path is, just go through what, because if you've noticed, I've split the nodes up into segments. Each segment contains a different piece of information. There's something we'll need to do, which again I'm not going to go through today, but you'll need to do some estimating to be able to complete this. So let me just zoom down here a second. So let me just draw up a node. Oops, that's an arrow. There we go. So there's a node, and it's split into multiple sections. So you got task name and ID in the middle. That's from our work breakdown structure. And then the way I've always remembered this is that the left-hand side of the node represents the start of the task. The right-hand side of the node represents the end of the task. So that line there is the start of the task there. This line here represents the finish. Get my handwriting, I'm writing at a slightly awkward angle. So if I go back up here, the reason we call the dependencies I've drawn here finish to start is because A has to finish before B can start. So your arrows go from the finish of A, so that line there, to the start of B, that line there. All right, so that's what that means. And that, by keeping that in mind, it helps remember what's in the node. So on the top left, we've got the earliest start, and the top right, we have the earliest finish. So the earliest start is the earliest I can start that task, the earliest I could do something. Where that comes from, we'll show you in a minute, and well, in the next video I do. The earliest start is the earliest I can start the task. The earliest finish is the earliest I can finish that task, relative based on the earliest start. So the thing in the middle then, at the top, is the bit I'll need to be estimating, which is the duration. I'll need to work out what the duration is going to be for each task, which I'll come back to in a minute. On the bottom then, we have the latest start on the bottom left. So that means the latest that task can begin and still finish the project on time. On the bottom right, we have the latest that task can finish and still deliver the project on time. And in the middle, something called total float, which will be the last thing I go through when I go in the next video, which I go through the actual calculations and everything in. So that is what's on the node. The duration is the important bit, really. We need that to be able to do the calculations on here. So estimating is done from a variety of different techniques. Again, I'm not going to go through the estimating on either of the videos I'm going to do for this. But the first video, this session, was purely just to go through how we create the network. The next video, I'll go through the critical path calculations and the maths behind it. Just wanted to do as an introduction first of all. But that's what we're going to use. And the duration, either estimating from previous projects or from an expert who has a database, maybe doing something with a variety of experts, maybe looking at breaking our project down into lots and lots of detail will help produce these estimates. Either way, we need a duration for each task, and that's done through estimating. And then we can populate that with our duration. So that's episode 1 of the critical path video. I'll see you in the next one. Hopefully this has been useful. And then, the next one will be all the maths. All right, so speak to you soon. Cheers, everyone.